The next is the big topic, which is cost volume profit. And here we look at applications like break even. How many units do you have to sell to cover your costs? Or target profit. I don't want to just cover my costs. I want to make a certain amount of money to live on. So I want to make $20,000 a month. So how much would I have to do to earn $20,000 a month? Third is contribution analysis. How much do you make per unit and how does that differ among different products? And fourth is sensitivity. If I vary certain assumptions, which are the assumptions that really drive the profitability? So that's identifying and seeing the range of possible outcomes under different scenarios, under scenario analysis. The good news is you can derive all of this. Furthermore, you probably could have done this before you came to HALT. So we're going to start with the profit formula and build from there. Trying it out, here are some pieces of data for us to just use, easier often to use numbers. Chilling Time produces one product, which is an ice cream bar. And the product is $1.50 as a selling price. Next, we have different costs that are broken out. On the left column here are the variable costs, things like the labor and material necessary to make the ice cream bar, and the manufacturing overhead that is variable. And these could be electricity, for example. We also have variable selling and administrative costs, which, as I mentioned, could be things like a selling commission. And so the total variable cost is $1.10, made up right here. And the fixed costs have both manufacturing and selling, and the total is $17.80. We've seen that number previously. The requirement is, what is the profit formula for this company? And secondly, what is the break even in terms of units? Specifically, how many ice cream bars must you sell to cover all your costs and have zero profit? That's what break even is. Break even is at the point where revenue equals all your expenses, so profit equals zero. What is the break even point in dollars? How many units and how many dollars? And I've replicated this in Excel. So you go there and look at CVP basics, and it's right here. Let's derive how profit formula works. Profit equals, and you probably know, it's revenue minus costs, right? But we notice that the costs here are lumped together. We have to break out the variable and fixed. Profit equals revenues minus the variable cost, but we also have to minus the fixed cost. So all I'm doing is breaking the detail. Now we're ready to make the big move. So profit equals, and instead of revenue, we have the assumption that everything has the same price. It's the price times the units sold minus variable cost. By definition also, for every unit, it's the variable cost for each unit. So variable cost per unit times the units minus fixed costs. Fixed costs don't need qualification because that's what it is. So that's what it is. That's the profit formula. And one way we could combine terms, so profit equals the price minus the variable cost per unit times units sold minus fixed cost. This is just a variation where we combine terms, and this part in the middle right here is called the unit profit contribution. For every unit sold, how much money is generated to cover fixed costs and profit. This has an alternate meaning that is quite useful in itself. Let's go into specifically applying it to chilling time and ice cream. What is the break-even point in units? First we say, well, what's the profit when we break even? It's zero. So zero equals the price, open parentheses, $1.50, minus the variable cost, which is $1.10, and that quantity times units, so that's the variable, let's just call it X, minus the fixed cost, but we also know that also, it's right here, $17.80, and that's the formula. Now notice we have an equation with one unknown, and we know how to solve that. We bring the $17.80 to the left side. $17.80 equals 150 minus 110 is 40 cents, 0.4 X, and now it's simply solving for X. X equals, and it equals 1780 divided by 0.4, and the answer is 4,450. And these are in units. We need to sell 4,450 units to break even. Now let's say you don't believe that works. So let's try it. Let's say, what's the revenue? I'll just do it this way. Revenue equals price, which is $1.50 plus $1.50 times this number. And let's say, what's our variable cost? Variable cost equals, and plus the $1.10 over here, 1.1 times the number of units sold, 4450, and that's variable cost. And then what's the fixed cost? Again, that is given on the left side right here, 1780. So let's try this out. So profit equals plus revenues minus variable cost minus fixed cost equals 0. So that's how we know we did it correctly. That was a test to see if the units right here are correct. I'll highlight that also, make it green. If we wanted to do sales in dollars, that equals sales price times the units sold, right? Pretty straightforward. That in this example is plus sales price is $1.50, and then that's going to be times, and the units sold are right here, 4450. That will equal plus that times 6,675 is the dollars. So I'll make that very clear. That's dollars, and those are units. This is break even in dollars, and we'll highlight that one too. This is the break even in units. We have the profit formula, which is right here, the general one, and we have it applied to chilling time, which is this formula, and this we set it to 0 for break even. That's CVP basics. This part here, my belief is that if we talked about it, you could have solved that because it makes sense, right? Profit equals revenues minus cost. And now we just break out detail to match the level of detail we have in our contribution income statements. So that's CVP. The next step is to say, well, what if we looked at it graphically as opposed to with algebraic formulas? So this red line represents the profit graph. And you notice that it goes up, up, up in the loss area until it hits this point. That point is exactly equal to the 6675, which is this number here. Break even in dollars at 6,675. The loss area is where the costs are higher than the revenues. So in this case, this is loss. And once we hit the break even, we're making profit. So the profit above here is the profit area. Profit here is the loss. So this graph is of the profit line. All right, so what happens if we break it into details as opposed to just one line? This looks a little scarier than it really is. So let's just start with this yellow line. Notice it starts at 0, 0, the origin, and it goes up at a constant slope, and that is revenue. Revenue is the dollars times the units. The axis here are units sold. The axis here are dollars. So when you start at 0, for every unit you sell, you make the amount of price, and so you just walk right up this yellow curve. Next, we have costs. So we have two kinds of costs. We have fixed costs and variable costs. So variable costs, again, start at 0. If you sell nothing, there is no cost. However, once you start selling, you're going to have additional costs. We're going to start by laying down the fixed costs, and that's 1780. And the variable costs start where it intersects. It will then go straight from there. Fixed costs are 1780 plus the number of units times the variable cost per unit of $1.10. The slope of this red line is $1.10. That's the change as we move from left to right. The slope of this yellow revenue line is the price. That illustrates graphically what we've seen in the profit formula.